Today we are going to talk about some more tangent properties. Now I hope you have already gone through the basics of tangent. If you haven't, please look at our earlier lessons on the tangent. So here we have a circle and this is a tangent as you can see it. Let me put the letters here. So let's say we have EAB. So EAB is a tangent when then A is the point of contact. And here we have an arc AB. And AB as an arc which has made an inscribed angle at X. So if inscribed angle is an angle made by an arc at the circumference. So we have an inscribed angle, and then we have another angle which is BA. Let's put it B dash. So we have another angle called BAB dash. So the property of tangent is that this angle is same as the inscribed angle. So let's go through it again. We have a tangent and we have at a point of contact A, and then we have an inscribed angle made by an arc AB at the point of contact. So the angle here is BAB dash is same as the inscribed angle made by the arc. Now you can also put some more rules of inscribed angle, some more properties where if this is an angle and this is a center of the circle, then this angle is again 2x, means twice the angle at the circumference. So let's solve some simple problems with that. So let's say here we have another tangent AB at a point of contact, let's say C, and we have a radius which is O here, and this is a line OC which touches the point of contact C, and then we have OB which is line joining between the end of the tangent, and then the OB cuts the circle at, let's say, at D. So here, as you see, this angle CDB, let me write it here, angle CDB equals to, so let's put that this angle equals to, as you know, 180 minus angle ODC. So in this particular problem, you are given this angle as an input. So this angle is given as 100 degree. And the problem is, what you have to find out, you have to find out all the remaining angles. This angle, this angle, this angle, this angle. So here you have two triangles, so you have to find all the remaining angles. And all you are given is 100 degrees. So 100 degree is, let's put it down, it's CDB equal to 180. So let's see how we can apply tangent formula and all the other formulas which you have learned to find out different angles. So one thing is very straightforward, which is ODC, which is this. So ODC equals to 180 minus CDB. I think there was a typo here. CDB is 100 degrees. So this is the input. CDB is the input. So 180 degree minus CDB equals 180 minus 100 equals 80. So this angle is 80 degree. So as we know that in the triangle OCD, so let's see OCD, if you see, this is the radius, both are radius, so this is an isosceles triangle. So the angles of this angle and this angle are same. So let me take a different color. So this angle and this angle both are same. So which is 180 degree. I'm sorry. So OCD, in the triangle OCD, if one angle is ODC is 80 degree, then other angle, which is OCB, equals to ODC equals to 80 degree. So we have found out this angle also. This angle also is 80 degree. So now if you consider OCD triangle, OCD again, the total angle are all 180 degree. So how can we find this angle? So angle COD equals 180 minus other two angles which I have marked in the red. So which is 80 plus 80. So that equal 180 minus 160. So 20 degrees. Correct? The figures are not, this figure is not drawn to scale, so that's why it may look a little different. But so this is 20 degree. So now if you look at this triangle OCB, here we have a tangent. So this angle, let's say this angle is same as the angle made at the, so here the angle angle ODCB. So let me write it carefully. Angle DCB equal to what? So if you see DCB, we can find out two ways. One very simple way is that we know that C is a point of contact and this is a 90 degree. Out of that we have already found the OCD angle, which is this angle. So that means this angle should be just 90 minus 80, which is 90 minus 80, which is we have found already in the earlier calculations, which is 10 degree. Now this is one way of finding it. The other way of finding it is if you apply this formula and you know that the angle, this one, is made by the arc CD. So which is, if you remember this one, here we have this angle and this angle is half of the angle made by the arc. So if you see this chord here, it made this angle which is 20 degree at the center. So it should be 20, half of 20, which is 10. So the other way of finding also this is that from this angle, also since this is 20 degrees, so half of this would be 10. So this is the other way of finding it. So anyway, so we have got now most of the angles. So here we have this is 10. This is the last remaining angle is this. So if you consider triangle OCB, in OCB we have angle, it is a right angle triangle. So we have 190 degree plus, which is, so we have one angle 90 degree, then this is 20 degree. So that makes it 110. So that means angle, this one would be 180. This is 110. So angle CDO equals 180 minus 110 equals 70 degree. Now again, figure is not drawn to scale, so that's why you are having this. It's looking a little difficult to in the eye to see that this doesn't look like 70 degree. But if you had drawn the figure to scale, probably it would have been a little easier for you to match the numbers. But anyway, so that makes for us to be able to figure out all the triangles of all the angles of the different triangles.